For level 3, the polynomials are no longer guaranteed to be the same degree, and they're no longer guaranteed to be in descending order, meaning the exponents aren't necessarily counting down. So we need to pay close attention to make sure that we're lining up our like terms. The first polynomial, we have 4a cubed, and then we have 8. And then the second polynomial, a cubed, would line up underneath our 4a cubed, but 7a does not have a like term from the first polynomial. So we'll write it next to it in its own column. So when we go to combine these, and we are adding them, we'll write an addition sign in front of each of these terms. And the 8 won't have anything to combine with, so you can choose to write a 0, or you can just draw an arrow indicating you know it's not going to change. The 7a won't have anything to combine with either, so you could write a 0a up here if you'd like, or you can just continue to write it down just like the 8. And the only thing we'll really have to add here is 4a cubed plus 1a cubed gives me 5a cubed. I don't have symbols in between my terms, so I'll need to add addition signs. Now, if you really want to take it a step further and write it in the best way possible, then you would want to make sure that you put this in descending order. So that means that the 5a cubed is going to need to come first. Next would be the 7a, because it's the next highest exponent. Finally, we'll have the 8. For example, 1b, our first polynomial, gives me 5b cubed, a negative b squared, and 6b. And in the second polynomial, we have 6, which does not have a like polynomial or a like term from the first polynomial. So it'll go in its own column. Negative 4b cubed will go underneath our b cubed term. And negative 3b will go underneath our b term. That means that my negative b squared has nothing to combine with, and neither does my 6. We are subtracting, so we'll write a minus in front of each of the terms on the second row. You can either write this as minus minus and change it to plus after, or you can go ahead and change those pluses to minuses. Either way, you should get negative 6. 6b plus 3b gives me 9b. Negative b squared. And then 5b cubed plus 4 more b cubed gives me 9b cubed. I already have a symbol in between here. I just need one here. For example, 2a. We have 8c for our first term, negative 4c cubed for the second term, and 6c to the fourth for our third term. The second polynomial, we have 8c again, and that'll line up underneath our c term. And then c cubed will need to line up underneath our c cubed term. We are combining those together with addition. So we'll put a plus sign in front of each of the terms on the bottom row. 6c to the fourth plus nothing gives me just 6c to the fourth. Negative 4c to the third plus 1c to the third gives me negative 3c to the third. 8c plus 8c gives me 16c. I have a symbol here, but I need to put one here. And again, if we really want to write best practice, this 6c to the 4th would go first, then c cubed, so negative 3c cubed, then our 16c. That would be descending order. For 2b, our first polynomial, 6d, and negative 5d squared. In the second polynomial, we have a 5d cubed, which doesn't have any polynomial or any, term to combine with, so it'll get its own column. 7d can combine with our 6d, so we'll write it underneath. And negative 6d squared can combine with our negative 5d squared, so we'll write it underneath. We are subtracting, so we'll write a subtraction symbol. That subtraction symbol changes this one to addition and then subtraction. So negative 5d cubed, negative 5d squared plus 6d squared gives me 1d squared, the 1 part being optional. 6d minus 7d gives me negative 1d. The negative 1, the 1 part is optional. We need a plus sign in between here, and we're going to write it in descending order. So negative 5d cubed is going to go first. Then d squared. And finally, we'll have minus d. Take a look at what this would look like in an application here. For geometry, we know that the perimeter, remember perimeter is all the sides added together, of a trapezoid is 8x plus 18, and we want to find the length of the missing base. So let's write out what we know. So what we know is that I can add up 2x from here plus x plus my 4x minus 3. I can add up all that together and I can get what the start of my perimeter is. So if I lined that up, I would have 2x for my first polynomial, x for my second polynomial, that would get to be written underneath, and then my third polynomial gives me 4x, and then a minus 3 has to be in its own column. We are adding those together, so 2x plus 1x plus 4x gives me 7x. And then the minus 3 comes down as well. So we know that the 3 sides here added together equals 7x minus 3. We also know that the perimeter is this 8x plus 18. So all 4 sides added together equal 8x plus 18. So if I take my perimeter and I subtract what we already are given or what we know, it will give me my missing part. So we can take and subtract the 8x plus 18 minus our 7x minus 3, and that will give me the missing part. So let's go ahead and do that really quick. 8x and 18 And then the next polynomial, 7x and negative 3. Hard to see that negative there. And we are subtracting. So subtraction symbol, and that subtraction symbol makes that a positive. So 8x minus 7x gives me 1x. 18 plus 3 gives me 21. So the length of this side down here is x plus 21.